Alright, this is Unit 7, Lesson 2 of our calculus class. Unit 7 is Applications of Integration. Lesson 2 is how to use that calculator to integrate for us. Because, yeah, we haven't done this before. So, for once I'm asking you to use a calculator. It's going to be great. The way you use calculator or integration on a graphing calculator is if you type in math 9, and I'll show you that in a minute. Real quick, if you have an older graphing calculator like a TI-83 or before, like I do, then the integration feature shows up as FNINT, and then a bracket, and then it asks for 4 inputs. If you have a TI-84 or newer, it gives you the actual math notation. There is a feature in the newer ones where you can show it in the old way if you really want that. There's no reason why somebody taking calculus in high school today would want that nostalgia, but whatever. The way it works is if you press math 9, it'll give you the FNINT or function integration, and it'll give you an open bracket. Your first of 4 inputs is the function you're integrating. The second input is the variable you're integrating with respect to, in other words, whatever dx is. And then your third input is the beginning interval a, and your fourth and final input is the endpoint of your interval b. So that's the setup. If you see this, don't freak out. It just means the same thing as our integral notation. Let's look at an example. So here's an example of a problem. We're finding area between 2 curves. The endpoints, or the beginning and end point of the interval, is not really easily seeable from the graph, certainly not to the third decimal place value. So what we're going to do to find those endpoints is when x is equal for f of x and g of x. So our interval of integration will set f of x equal to g of x, and we'll solve for x. This is a quadratic, so we use quad formula. 1/6 minus the square root of 97 over 6. Well, if I subtract that square root instead of adding it, that's definitely going to be the earlier point. So a would be 1/6 minus root 97 over 6, and b would be 1/6 plus root 97 over 6. Our top function in our interval is g of x, so we'll integrate from a to b of g of x, the top function, minus f of x, the bottom function. And we're integrating with respect to x. So I'm going to plug in my a value and my b value. And in this case, I don't really want a decimal yet, so I'm just going to plug those in. You can throw those into your calculator and just get a decimal. If you round it to the third decimal place value, you should be just fine. You won't have any rounding issues, not for our homework at least. And then our top function g of x minus our bottom function f of x. Here's our setup. If I simplify our algebra, I get negative 3x squared plus x plus 8, and there should be a dx right here. Let me fix that. Cool. So, how do you get from here to the answer 17.691? Let me pull up my graphing calculator simulator. Thank you, TI, for the free 180-day trial. Since we're doing this class in a semester, 180 days is enough to get the whole thing done without asking the school to buy a subscription, because we don't have the money for that. Haha. 21 days left. We'll get through AP test for this bad boy. So, how do I get this? Let's clear this out. Go from scratch. So, math 9, and if I press 9, it's going to give me the function integration feature. And here is set up like this. Again, if you have an older calculator, it'll show up. Math 9 will show up like this, function integration, but we'll stick with this for now. So f of x is going to be negative 3, the xt theta n button I'm going to use for my x, squared plus x plus 8, and then comma, and then the derivative or the integral we're taking respect to is respect to x, comma, and then we're going to look at our starting point and end point. So our starting point next is negative 1.474, comma, and then our end point was 1.808, close bracket, and here's our answer, 17.691. What you could do, instead of typing in the decimals for the starting point and end point, you could throw these expressions into the starting point and the end point just as they are. It'll give you a more exact answer. That's totally fine. You could even leave, if you're worried about simplifying, this is a pretty easy example, but if you're worried about simplifying your g of x minus f of x, you could just leave the function as is and put that in your calculator. It all works. It all works. So that's that. Let's move on. Alright, so that's how you use your graphing calculator to integrate for you. Again, it's just math 9, and that pulls up the function integration tool, which is pretty sweet.